Early March 1944, a lone B-29 Superfortress touches down at Royal Air Force Street, Morgan in Cornwall, England. The aircraft, nicknamed Hobo Queen, has just completed a transatlantic journey that should be impossible. Around the tarmac, British ground crews stop what they're doing and stare. The bomber is enormous, dwarfing every aircraft on the field. Its wingspan stretches 141 feet. Its fuselage rises nearly 3 stories off the ground. But what the ground crews can't see, what the Luftwaffe reconnaissance pilots photographing this arrival from 30,000 feet above don't yet understand, is that this single aircraft represents a revolution in strategic bombing that will render Germany's entire air defense network obsolete. Within hours of Hobo Queen's landing, the photographs are racing eastward. Luftwaffe intelligence officers in Berlin huddle around grainy images of the massive bomber sitting placidly on British soil. They measure the wingspan, estimate the fuselage volume, calculate the probable bomb load. The numbers they arrive at are deeply troubling. If this aircraft is operational in England, if more are coming, then every assumption the Reich has made about defending its airspace is about to become irrelevant. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But here's what those intelligence officers don't know yet, what they won't discover for months. Hobo Queen isn't in England to bomb Germany. She's there to make them think she is. The entire visit is theatre, a carefully orchestrated deception designed to convince the Luftwaffe that B-29 seconds are destined for Europe, when in reality, every Superfortress rolling off American production lines is heading to the Pacific. The psychological operation is working perfectly. Hobo Queen will spend 2 weeks touring British airfields: Glatton, Knettishall, Horsham Street. Faith, deliberately flying in daylight where German reconnaissance can photograph her, where local newspapers can publish her image, where rumours can spread like fire through occupied Europe. The bomber even appears in the Völkischer Beobachter, the Nazi Party's official newspaper, exactly as American planners hoped. The headline practically writes German fears for them. But the real damage isn't happening in the press. It's happening in the engineering offices and planning departments, where Luftwaffe officers are frantically calculating what it would take to intercept a bomber that operates where no German fighter can comfortably fly. The B-29 Superfortress represented a quantum leap in strategic bombing capability, and German intelligence knew it. Their analysts had been tracking Boeing's development program since 1941 through a network of industrial spies, technical journals, and captured American documents. What they learned kept them awake at night. The Superfortress could cruise at altitudes above 30,000 feet, not just briefly, but for hours. Its pressurized cabin meant crews could operate in comfort at heights where German airmen would be struggling with oxygen starvation and freezing temperatures. And unlike the B-17 seconds and B-24 seconds currently pounding German cities, the B-29 could potentially fly completely above the effective ceiling of Germany's Flak defences. Standard German 88mm Flak 36 and Flak 37 anti-aircraft guns had a theoretical maximum altitude of around 26,000 feet. The improved Flak 41 could reach 37,100 feet under perfect conditions, but hitting a manoeuvring target at that altitude was nearly impossible. German predictors, those sophisticated mechanical computers that had been so deadly against B-17 formations, were designed around targets operating between 20 and 25,000 feet. A bomber cruising at 35,000 feet or higher existed in a realm where ballistic calculations became guesswork. The engineering that made this possible was what truly terrified German analysts. The B-29's Wright R3000, 350 duplex Cyclone engines each produced 2,200 horsepower and were equipped with 2 General Electric turbo superchargers per engine. 8 turbo superchargers in total, spinning at over 20,000 RPM, compressing thin stratospheric air back to sea level density before feeding it to the engines. The Germans understood turbo supercharging technology. They'd experimented with it throughout the 1930s, but they'd never successfully packaged it into a production fighter in quantities that mattered. Their manufacturing base couldn't reliably produce the exotic high-temperature alloys needed for turbine blades that had to survive exhaust gases at 1700 degrees. The precision bearings required for turbines spinning at such insane velocities were beyond the capacity of Germany's increasingly bomb-damaged machine tool industry. Even if they solved the technical problems, retooling factories to produce turbo-supercharged fighters would halt current production for months, something Germany's desperate military situation couldn't afford. Oberst Hajo Hermann, one of the Luftwaffe's most innovative tactical thinkers, was among the first to grasp the implications. In a memo to Reichsmarschall Hermann Göring, dated March 21, 1944, just days after Hobo Queen's arrival in England, Hermann laid out the problem with brutal clarity. If the Americans deployed B-29 seconds to Europe in numbers similar to their B-17 deployments, German day fighters would be unable to intercept them effectively. The Messerschmitt Bf-109G, backbone of the Luftwaffe's fighter force, had a service ceiling of 38,000 feet on paper, but became dangerously sluggish above 35,000. Its mechanically driven supercharger was consuming so much power at that altitude that the aircraft could and barely maintain level flight, much less execute combat maneuvers. The Focke-Wulf 190A, newer and more powerful at low altitudes, was even worse at height. Its BMW 801 radial engine with a single-stage supercharger peaked around 34,000 feet before becoming nearly uncontrollable. Hermann's memo concluded with a recommendation that would send Focke-Wulf's design teams into overdrive. Germany needed a dedicated high-altitude interceptor immediately, not a modified existing design but an entirely new aircraft optimized for combat above 30,000 feet. The timeline he proposed was impossibly aggressive. Design, prototype, testing and production in less than 9 months. Any reasonable engineer would have called it fantasy. But Kurt Tank, Focke-Wulf's chief designer, didn't have the luxury of reason. Tank was already working on high-altitude variants of his FW-190, but Hobo Queen's appearance accelerated everything. The rumors about B-29 deployment to Europe, rumors that American intelligence had deliberately planted, gave him the political leverage to push his most ambitious design forward. What emerged from his drawing boards that spring would become the TAR-152, named with Tank's own initials, a fighter specifically engineered to hunt bombers in the thin air above 40,000 feet. The development program for the TAR-152H, the high-altitude variant, began in earnest in April of 1944. Tank selected several existing FW-190 prototypes to be radically modified. The changes were extensive, nearly creating a new aircraft. First, the wings. The stubby, low aspect ratio wings that made the FW-190 so maneuverable at low altitude were terrible at height, where thin air provided less lift. Tank designed new high aspect ratio wings with 40% more span than a standard FW-190, stretching the wingspan to 47 feet. The longer wings generated more lift in thin air, but they came with penalties. Roll rate suffered, and the wings added weight. Tank didn't care. This aircraft wasn't being designed for dogfighting. It was being designed to catch B-29 seconds. Next, the engine. Tank initially wanted to use the Daimler-Benz DB603, which offered excellent high-altitude characteristics, but German Air Ministry officials pushed back. The DB603 had been problematic in earlier FW-190C prototypes, and the ministry didn't want production delays. Tank compromised, selecting the Junkers Jumo 213E, a 12-cylinder liquid-cooled engine rated at 1,750 horsepower at takeoff. But the Jumo 213E wasn't enough by itself. To reach the altitudes necessary to intercept B-29 seconds, the TAR-152H would need chemical assistance. Tank specified 2 boost systems. The MW50 system injected a 50-50 mixture of methanol and water into the supercharger, increasing power at low and medium altitudes. The GM1 system injected nitrous oxide into the engine at high altitude, allowing it to maintain power where the air was too thin for normal combustion. With both systems engaged, The Jumo 213E could produce over 2100 horsepower briefly and maintain 1740 horsepower at 32,800 feet. But altitude performance meant nothing if the pilot couldn't function at those heights. Standard German fighters had unpressurized cockpits. Pilots relied on oxygen masks and heated flight suits, which worked adequately up to about 30,000 feet. Above that, human performance degraded rapidly. Reaction times slowed, decision-making suffered, and prolonged exposure could cause permanent neurological damage. The B-29's crews, by contrast, sat in fully pressurized comfort, able to operate effectively for hours, at altitudes that would incapacitate a German pilot in minutes. Tank solved this by designing a pressurized cockpit for the Ta-152H, the first such installation in a German production fighter. The canopy was sealed by a circular tube filled with rubber foam, inflated by a compressed air bottle. A Knorr 310ths air compressor maintained cockpit pressure at 0.37 bar above ambient pressure. Once the aircraft climbed above 8,000 meters, roughly 26,000 feet, the windscreen was double glazed, 6 millimeters of outer glass, 3 millimeters of inner glass, with a 6 millimeter gap containing silica gel capsules to prevent fogging. It sounds simple described this way, but engineering a pressurized cockpit that could withstand combat damage without explosive decompression required solving dozens of technical problems. Every control cable, every instrument line, every electrical connection that penetrated the pressure vessel needed special seals. The cockpit door required a complex locking mechanism that could maintain pressure even under combat G-loads. The armament was deliberately heavy. Tank knew that B-29 seconds were tough aircraft, built with redundant systems, and capable of absorbing tremendous punishment. The Ta-152H couldn't afford multiple attack passes. It needed to kill with one burst. He installed a 30mm Mk108 cannon in the propeller hub and two 20mm MG151 over 20 cannons in the wing roots. The 30mm was a devastating weapon. A single hit from an Mk108 shell could sever a B-17's tail, and the B-29 was only marginally more robust. But the Mk108 had terrible ballistic characteristics, a muzzle velocity so low that hitting a maneuvering target required deflection shooting skills that few pilots possessed. The 20mm MG151 seconds were more accurate, with higher muzzle velocity and better range, intended to walk fire onto the target before the pilot unleashed the 30mm. By July 1944, the first genuine Ta-152H prototypes were flying. Test pilots reported extraordinary high-altitude performance. At 41,000 feet, using GM1 boost, the aircraft could reach 472 miles per hour, faster than most fighters could, manage at sea level. The service ceiling exceeded 48,000 feet, higher than any Allied bomber could operate. But the development was rushed, dangerously so. Kurt Tank's team was being pushed to deliver an operational aircraft before the end of the year, and corners were being cut. Stability issues remained unresolved. The fuel system had reliability problems. Some test aircraft crashed, killing pilots. One Ta-152 prototype suffered complete engine failure when a hydraulic valve was accidentally installed in the fuel line during assembly, a mistake that shouldn't have been possible with proper quality control, but was becoming increasingly common as Germany's industrial base crumbled under Allied bombing. Pre-production Ta-152H0 aircraft began rolling out of the Focke-Wulf factory at Cottbus in November 1944. These weren't quite the aircraft Kurt Tank had envisioned. They lacked the outer wing fuel tanks that would have extended range. They didn't carry GM1 boost because the nitrous oxide containers adversely affected the aircraft's center of gravity, and there hadn't been time to redesign the installation. The MW50 water methanol system was present but unreliable. In essence, the Luftwaffe was accepting aircraft that were only partially finished because the alternative was having no high-altitude capability at all. Production Ta-152H1 fighters started reaching operational units in January 1945. By then, The strategic situation had evolved in ways that made the entire program seem tragically ironic. The B-29 seconds never came to Europe. Every superfortress that entered service was committed to the Pacific Theater, where they were systematically burning Japanese cities to ash from altitudes Japanese fighters couldn't effectively reach. Hobo Queen's mission had been a complete success as deception. The Luftwaffe had diverted precious engineering resources, manufacturing capacity, and rare materials into building a weapon to counter a threat that would never materialize over Germany. The TAR 152 seconds that did reach squadrons faced a different reality. They were assigned to defend Messerschmitt Me-262 jet fighter bases, flying combat air patrol to protect the jets during their vulnerable takeoff and landing phases. They fought P-51 Mustangs and P-47 Thunderbolts at medium altitudes, where their high-altitude optimizations were irrelevant. A few pilots reported the aircraft's exceptional qualities when they could use its strengths. Oberleutnant Willy Reschke of Jagdgeschwader 301 flew multiple combat sorties in the TAR 152H and reported that nothing the Allies fielded could match it above 30,000 feet. But those engagements above 30,000 feet never happened, because Allied bombers and fighters in Europe operated where the air was thicker and Flak could reach them. The TAR 152H was a solution to a problem that existed only in German imagination, carefully cultivated by American psychological warfare. Kurt Tank had designed a masterpiece, but he designed it to fight ghosts. The irony went deeper than just wasted resources. While Focke-Wulf was perfecting a piston-engine fighter to intercept B-29 seconds that would never come, Boeing was already flying B-29 seconds over Japan at altitudes the TAR 152H could theoretically reach, but where combat effectiveness was academic. And those B-29 seconds weren't even using their high-altitude capability the way German planners expected. By March 1945, General Curtis LeMay had converted his B-29 force to low-altitude night incendiary attacks, flying at 5,000 to 8,000 feet, where Japanese flak and fighters could theoretically engage them, but where the psychological impact of massed firebombing was maximized. The altitude advantage that had driven German interceptor development, the capability that Kurt Tank had sacrificed everything else to achieve, turned out to matter less than operational flexibility and payload capacity. The real revolution wasn't how high the B-29 could fly. It was that it could choose when and where to fly, operating in whatever profile the mission demanded, while enemy defenses struggled to adapt. German engineering had responded brilliantly to intelligence about B-29 capabilities. They'd created the TAR 152H in record time, solving technical problems that would have taken peacetime development programs years to address. But they'd been responding to a threat that American planners had deliberately exaggerated through operations like Hobo Queen's Tour. The bomber sitting on that British airfield in March 1944 wasn't a harbinger of B-29 operations over Germany. It was bait, and the Luftwaffe had taken it completely. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The bitter irony of the TAR 152H's development became apparent in the first weeks of 1945. While German pilots were climbing into their pressurized cockpits, preparing to hunt bombers at 40,000 feet, those bombers were fighting a completely different war 7,000 miles away. On the night of March 9th through 10th, 1945, 334 B-29 Superfortresses departed their bases in the Mariana Islands bound for Tokyo. Not one of them flew above 8,000 feet. General Curtis LeMay had made a decision that would have seemed insane to any bomber commander trained in European doctrine. He stripped the defensive guns from his aircraft to save weight. He ordered his formations to attack at night. And most shockingly, he commanded them to descend to altitudes between 5,000 and 7,000 feet, well within range of Japanese anti-aircraft fire. The crews thought he was sending them to their deaths. They were flying the most technically advanced bomber in the world, capable of operating in the stratosphere, where no enemy fighter could touch them, and LeMay wanted them down in the weeds where every anti-aircraft gun in Tokyo could reach them. But LeMay understood something that German intelligence analysts, focused on altitude capabilities and turbo supercharger specifications, had missed entirely. The B-29's revolutionary technology wasn't just about how high it could fly. It was about operational flexibility, the ability to choose the mission profile that best accomplished the objective. High-altitude precision bombing from 30,000 feet looked impressive in planning documents, but over Japan, it had been a disaster. Between November 1944 and early March 1945, B-29 seconds had flown dozens of high-altitude precision raids against Japanese industrial targets. The results were abysmal. Only 20% of aircraft managed to bomb their primary targets. The jet stream, a meteorological phenomenon that American meteorologists were only beginning to understand, created winds exceeding 250 miles per hour at altitudes above 23,000 feet. Bombs released from B-29 seconds at cruise altitude were being blown miles off course before they reached the ground. The mechanical complexity that made high-altitude flight possible was simultaneously working against mission effectiveness. The Wright R-3350 engines, magnificent pieces of engineering on paper, were proving temperamental in operational service. Crews reported engine failures, overheating, and fires with alarming frequency. The engines required constant maintenance, specialized tools, and replacement parts that were difficult to supply across thousands of miles of Pacific Ocean. B-29 seconds were aborting missions, turning back before reaching Japan, landing at emergency fields, or ditching in the ocean. The loss rate from mechanical failures exceeded losses from enemy action. And then there was the bomb load problem. Flying at maximum altitude with full fuel loads meant carrying fewer bombs. The mathematics were brutal. Every 1,000 feet of altitude gain cost payload capacity. A B-29 flying to Tokyo at 32,000 feet could carry roughly 7 tons of bombs. That same aircraft, flying at 6,000 feet, could carry nearly 12 tons. LeMay did the calculations and concluded that altitude advantage meant nothing if you weren't putting enough explosives on target. The night of March 10th became known as Operation Meeting House, though to the crews who flew it and the civilians who endured it, no operational codename could adequately describe what happened. The B-29 seconds arrived over Tokyo in waves, the lead aircraft dropping napalm markers in a massive X pattern across the Shitamachi district, the densely populated working-class neighborhoods east of the Imperial Palace. The Pathfinders were followed by the main force, 279 bombers carrying E-46 cluster munitions filled with M69 incendiary bomblets. Each cluster bomb released 38 individual incendiaries at altitudes between 2,000 and 2,500 feet. The M69 seconds were diabolical devices, cylinders of jellied gasoline wrapped around white phosphorus igniters. They punched through thin roofing material or struck the ground, then detonated 3 to 5 seconds later, spraying burning napalm in all directions. Japanese houses, constructed primarily of wood and paper to survive earthquakes, burned with terrifying efficiency. Individual fires merged into conflagrations. Conflagrations merged into a general firestorm. Within 2 hours, 15.8 square miles of central Tokyo ceased to exist as anything recognizable. The updrafts from the fires were so powerful that B-29 crews flying at 7,000 feet reported being thrown thousands of feet upward by thermal columns. Some aircraft were flipped inverted. Bombardiers in the trailing waves described being able to read their bomb release documents by the light of fires visible from 60 miles away. The human toll was catastrophic. Post-war analysis estimated that approximately 100,000 civilians died that night, most from burns or asphyxiation as the firestorm consumed all available oxygen. Another million were rendered homeless. It was the single most destructive bombing raid in human history, exceeding the damage that would later be inflicted by atomic weapons at Hiroshima and Nagasaki. And the B-29 seconds accomplished it while flying at altitudes that the standard German 88mm Flak 36 could easily reach, altitudes where Messerschmitt Bf 109 seconds and Fokker-Wulf 190 seconds could have torn them apart if they'd been defending Tokyo instead of Berlin. The tactical shift was complete and permanent. LeMay had proven that the B-29's true value wasn't its ability to fly at 40,000 feet. It was its range, its payload capacity when flying at medium altitude, and its operational flexibility. Over the following months, American B-29 seconds conducted systematic low-altitude incendiary attacks against Japanese cities. Osaka, Nagoya, Kobe, Yokohama, 66 cities in total by the time Japan surrendered. The bombers that German engineers had anticipated fighting at stratospheric altitudes were instead operating in a profile that made their high-altitude capabilities almost irrelevant. Meanwhile, in Germany, the Ta-152H pilots of Jagdgeschwader 301 were discovering their own form of irony. The squadron received its first operational aircraft on January 27, 1945. 12 Ta-152Hs were ferried from the Focke-Wulf factory at Cottbus to the airfield at Altenau, southeast of Berlin. Oberleutnant Willy Reschke, one of the pilots selected for the unit, later described his first encounter with the aircraft. The wingspan seemed impossibly long for a fighter. The fuselage stretched forward in an ungainly manner to accommodate the Jumo 213E's length. It looked less like a fighter than a reconnaissance aircraft someone had decided to arm. But when Reschke took off for the first time, climbing away from Altenau in aircraft number Black 3, the Ta-152H revealed its capabilities. At 10,000 feet, the aircraft was nimble, responsive. At 20,000 feet, where other German fighters were gasping for air, the Ta-152H was still accelerating. At 30,000 feet, Reschke engaged the MW-50 water methanol injection system and watched the manifold pressure climb. The aircraft that had looked so awkward on the ground was transformed at altitude. This was exactly what Kurt Tank had promised, a fighter that owned the high ground. The question was whether that high ground still mattered. The first combat mission came on February 8, 1945. A handful of Ta-152Hs scrambled to intercept American bombers reported approaching Berlin. The pilots climbed eagerly, anticipating their first chance to demonstrate the aircraft's capabilities against high-altitude B-17 formations. They never made contact. By the time the Ta-152 seconds reached 30,000 feet, the American bombers were already departing the target area, and P-51 Mustang escorts were positioned between the Germans and their prey. On February 21st, Oberfeldwebel Josef Kiel, flying Ta-152H Green 3, claimed to have shot down a B-17 over Berlin at 16:30 hours. It would be recorded as the first victory credited to a Ta-152 pilot. But post-war analysis found no corresponding American loss that day. Either Kiel's claim was mistaken, or he'd damaged a bomber that managed to return to base. The uncertainty surrounding this first claimed victory would become emblematic of the Ta-152's entire operational career. Nothing about the aircraft's service would match the precision of its engineering. The reality facing JG 301 inches early 1945 bore no resemblance to the scenarios that had driven the Ta-152's development. German intelligence had prepared for B-29 operations over Europe, for high-altitude strategic bombing, for a continuation of the air war that had defined 1943 and 1944. Instead, the Luftwaffe was collapsing under the weight of fuel shortages, pilot attrition, and the Red Army's advance from the east. On March 2nd, 12 Ta-152Hs took off from Sachau, the unit having been forced to relocate as Soviet forces approached their previous base at Altenau. The mission was to intercept American bombers heading toward targets in central Germany. Over 1,200 B-17 seconds and B-24 seconds were airborne that day, escorted by more than 700 fighters. The Ta-152 pilots climbed toward the bomber stream with confidence. This was their moment. This was what they'd trained for. Then German Bf-109 seconds from another Jagdgeschwader attacked them. The 109 pilots, who had never seen a Ta-152 before, misidentified the long-winged fighters as enemy aircraft, possibly American P-51 seconds or British Tempests. Radio calls to break off the attack were either not heard or not believed. The Ta-152 pilots found themselves in the absurd position of fighting other German fighters while American bombers cruised overhead unmolested. The superior climb rate and maneuverability of the Ta-152 seconds allowed them to evade the attacks without losses, but the mission was aborted. The Americans bombed their targets and returned to England. Kurt Tank's high-altitude interceptor had been rendered irrelevant by friendly fire and organizational chaos. This incident perfectly encapsulated the Luftwaffe's situation in early 1945. Even when the Germans possessed superior technology, they lacked the training, communication, and organizational coherence necessary to employ it effectively. The Ta-152H could theoretically climb to 48,000 feet. But what did that matter when ground controllers couldn't coordinate intercepts properly, when friendly aircraft didn't recognize your silhouette, when fuel shortages meant you could only fly one sortie per day? The few successful Ta-152 engagements that did occur demonstrated the aircraft's capabilities while simultaneously highlighting the futility of its mission. On March 1st, Josef Kiel claimed a P-51 Mustang shot down over Berlin. This victory was likely genuine, as American records show P-51 losses in that area on that date. But Kiel engaged the Mustang at medium altitude, somewhere around 15 to 20,000 feet, not the stratospheric heights the Ta-152 was designed to dominate. The Mustang pilot had probably been strafing ground targets or had descended to chase German fighters. At medium altitude, the Ta-152's high-altitude optimizations were less relevant. Kiel won the engagement through piloting skill and the aircraft's heavy armament, not because of its pressurized cockpit or GM-1 boost system. On April 10th, 4 Ta-152Hs, led by Oberstleutnant Fritz Aufhammer, the Geschwader commander, scrambled from Sachau to patrol over Braunschweig. At 10,000 meters, roughly 32,800 feet, Kiel spotted a formation of P-47 Thunderbolts below, silhouetted against the setting sun. The Ta-152 seconds had altitude advantage, exactly as Kurt Tank had envisioned. They dove on the Thunderbolts, Kiel fired, and claimed one destroyed. The engagement lasted seconds before the remaining P-47 seconds scattered. This should have been vindication. A Ta-152, using its superior altitude capability, had bounced American fighters exactly according to doctrine. But even this small victory carried bitter irony. The P-47 seconds, with their turbo-supercharged engines, were perfectly capable of operating at 32,000 feet. They'd been flying low, probably conducting ground attack missions. If they'd been at cruising altitude, maintaining combat air patrol above bomber formations, the altitude advantage would have been minimal or non-existent. The Ta-152 had caught them at a disadvantage through luck, not through inherent technological superiority over the enemy's high-altitude capabilities. April 14th brought one of the Ta-152's most famous engagements, though its details remain disputed. 3 Ta-152Hs from the Geschwader staff, flown by Aufhammer, Oberfeldwebel Sepp Sattler, and Willy Reschke, took off from Neustadt Gluhe to intercept RAF Tempests that had been spotted attacking the Ludwigslust rail yard. The Tempest was a formidable low to medium altitude fighter, fast and heavily armed, but with conventional supercharging that limited its high altitude performance. On paper, the Ta-152 should have dominated, but this engagement wouldn't occur on paper or at high altitude. It happened in the weeds, below 5,000 feet, where the Tempests were operating. As the Ta-152 seconds dove to intercept, Sattler's aircraft went into an uncontrolled descent and crashed, killing him instantly. The cause remains unclear: mechanical failure, pilot error, or possibly combat damage from the Tempest's defensive fire. Reschke and Aufhammer engaged the British fighters in a turning fight at low altitude. Rishka later claimed that one Tempest stalled during evasive maneuvers and crashed. RAF records confirm that Warrant Officer Owen Mitchell of 486 Squadron was killed in a crash during this engagement, though whether he was shot down or lost control during violent maneuvering remains ambiguous. What's certain is that the TAR 152 seconds gained no advantage from their high-altitude optimizations. The long wings that generated so much lift in thin air created additional drag at low altitude. The pressurized cockpit was meaningless below 8,000 feet. The MW-50 boost system, designed to provide power at medium altitudes, was engaged. But the Tempest's Napier Sabre engine produced 2,400 horsepower at sea level without any boost system. At the altitudes where this fight occurred, the aircraft were roughly evenly matched, and the outcome depended on pilot skill rather than technological advantages. By late April 1945, the TAR 152 program had effectively ended. Production at Cottbus ceased as Soviet forces overran eastern Germany. The Marienburg assembly facility had already fallen to the Red Army. Spare parts became impossible to obtain. JG 301's surviving TAR 152 seconds were pooled in the Geschwader staff flight because the unit couldn't maintain enough aircraft to equip an entire squadron. At any given time, perhaps 10 to 15 TAR 152Hs were operational across the entire Luftwaffe. Compare this to the 15,000 P-47 Thunderbolts produced, or the 8,000 P-51 Mustangs, or the 3,900 B-29 Superfortresses that rolled off American production lines. The final TAR 152 combat missions were flown in the last days of April during the Battle of Berlin. Kahl and Reshka both claimed victories against Soviet Yak-9 fighters. These engagements occurred at medium to low altitudes, where Soviet ground attack aircraft operated. Once again, the TAR 152's high-altitude capabilities were irrelevant. The aircraft were being used as standard fighters in a desperate ground support role, defending Berlin against overwhelming Soviet forces. By May 7, 1945, when Germany surrendered, the surviving TAR 152H pilots had achieved perhaps 7 confirmed victories in total. 4 were credited to Joseph Kahl, making him the only ace flying the type. 3 were credited to Willy Reshka, though, as mentioned, at least one of those remains disputed. Against these 7 victories, the Luftwaffe lost 4 TAR 152 seconds in air combat, plus numerous others to accidents, mechanical failures, and destruction on the ground during bombing raids. The kill-to-loss ratio was roughly 1-to-1 if you were generous with the victory claims, far below the rates that German pilots had achieved earlier in the war flying inferior aircraft. But statistical analysis misses the point. The TAR 152H wasn't defeated by Allied fighters. It was defeated by strategic reality. Kurt Tank had designed a masterpiece of high-altitude aeronautical engineering. The aircraft could do everything promised. It could climb to 48,000 feet. It could cruise at 472 miles per hour at 41,000 feet using GM1 boost. The pressurized cockpit worked. The Jumo 213E engine, when properly maintained, was reliable and powerful. The aircraft was exactly what German intelligence had concluded was necessary to intercept B-29 formations operating at stratospheric altitudes over European cities. But those B-29 formations never materialized. American planners had successfully deceived the Luftwaffe into diverting resources toward countering a threat that existed only in German imaginations. Hobo Queen's 2-week tour of British airfields in March 1944 had accomplished its mission perfectly. It had convinced German intelligence that B-29 deployment to Europe was imminent, forcing the acceleration of high-altitude interceptor programs like the TAR 152. Those resources, engineering talent, rare materials, production capacity, could have been directed elsewhere. Toward improving the FW-190D, which was entering service in useful numbers, toward supporting Me-262 jet fighter production, Toward literally anything that might have made a tactical difference in the air war, Germany was actually fighting rather than the one they feared they might fight. The real B-29 seconds, meanwhile, were systematically reducing Japanese cities to ash, operating in mission profiles that made German high-altitude fighter development seem tragically misguided. When B-29 seconds did operate at high altitude over Japan, Japanese interceptors couldn't effectively reach them. The Mitsubishi J-2M Raiden and Kawasaki Ki-61 Hien had service ceilings around 33,000 feet, barely adequate to intercept B-29 seconds cruising at 30,000, and completely inadequate if the superfortresses climbed higher. But the Japanese never developed anything comparable to the Ta-152H. They never created a specialized stratospheric interceptor because their industrial base couldn't support it. Japan lacked the advanced alloys, the precision manufacturing, and the engineering expertise necessary. German engineers, possessed of all those advantages, created the Ta-152H to fight an enemy that would never arrive in their skies. Japanese engineers, lacking those advantages, never attempted such a program, and in the end, it made no difference to either nation's fate. LeMay's switch to low-altitude tactics rendered altitude advantage irrelevant. The B-29 seconds burning Tokyo, Osaka, and Nagoya flew at altitudes where even obsolete Japanese fighters could theoretically intercept them. But the sheer numbers, the darkness, the navigational challenges, and the inadequacy of Japan's air defense infrastructure meant that Japanese fighters achieved negligible results regardless of altitude. Technology didn't determine the outcome. Operational flexibility, industrial capacity, and strategic decision-making did. By mid-1945, American B-29 formations were suffering acceptable loss rates despite flying in vulnerable low-altitude profiles. Japanese Flak batteries lacked the sophisticated predictors that German batteries used. Japanese fighters lacked radar-guided night fighter capabilities. Japanese cities lacked adequate civil defense infrastructure. The combination meant that even when B-29 seconds flew low, even when they operated in conditions where they should have been vulnerable, they survived in sufficient numbers to continue the campaign. The final supreme irony came in August 1945. The two atomic bombs dropped on Hiroshima and Nagasaki were delivered by B-29 seconds Enola Gay and Bockscar. Both aircraft flew their missions at approximately 31,000 feet, well within the B-29's high-altitude capability, but not requiring the extreme ceiling that had so concerned German intelligence. The atomic missions used altitude primarily for safety, allowing the aircraft to escape the blast radius after bomb release, not because conventional defenses threatened them at lower altitudes. If German engineers in 1944 could have foreseen that the B-29's most historically significant missions would occur at comfortable cruising altitude, delivering weapons that represented a complete obsolescence of conventional strategic bombing, they might have questioned the entire premise of high-altitude interceptor development. But foresight is not possible in wartime. You plan for the threats intelligence suggests are coming. You develop capabilities based on enemy intentions you can observe or infer. German intelligence observed B-29 development. They correctly identified its high-altitude capabilities. They reasonably concluded it would be deployed to Europe using the same strategic bombing doctrine that B-17 seconds and B-24 seconds employed. They were wrong about everything except the technical specifications. The Ta-152H stood as testament to the limits of technical excellence divorced from strategic reality. It was, by most measurable parameters, the finest piston-engine high-altitude fighter of World War II. It could outclimb, outrun, and outperform Allied fighters in the thin air above 40,000 feet. It incorporated pressurization technology, boost systems, and aerodynamic refinements that represented the peak of piston-engine fighter development. And almost none of that mattered because the air war it was designed to fight never happened over Germany. The few pilots who flew it in combat spoke of the aircraft with something approaching reverence mixed with frustration. Reschke later said that, at altitude, the Ta-152H felt like it could do anything, The controls remained responsive at heights where other fighters became sluggish and dangerous. The visibility from the pressurized cockpit was excellent. The aircraft felt solid, purposeful, engineered rather than improvised. But those same pilots found themselves using this sophisticated machine to intercept Soviet ground attack aircraft at 5,000 feet, or bouncing Mustangs that were strafing trains, or sitting on the ground unable to fly because no fuel was available. The contrast between the aircraft's capabilities and the missions it actually flew must have been maddening. One surviving TAR-152H exists today. Aircraft number 150020, a pre-production H-0 model, resided for decades at the Smithsonian's Paul E. Garber facility in Maryland. It was recovered by American forces in Germany in May 1945, likely captured on an airfield before it could be flown or destroyed. The aircraft sits in storage, a museum piece, testament to engineering ambition and strategic miscalculation. Its condition reflects the desperate circumstances of its construction. Build quality inconsistencies, slave labor assembly, shortcuts taken because Germany's industrial infrastructure was crumbling under Allied bombing, but the fundamental design remains visible. Those long wings, that pressurized cockpit, the installation spaces for MW-50 and GM-1 boost systems. Everything Kurt Tank specified to create an aircraft that could hunt bombers at altitudes where other fighters failed. The aircraft will eventually be restored and displayed, and visitors will read plaques explaining its capabilities and limited service history. Few will understand the deeper irony. This machine was designed to fight American bombers that came to Europe. But those bombers, the B-29s, never came. They were busy somewhere else, fighting a different war using different tactics, proving that operational flexibility mattered more than any single technical advantage. The TAR-152H could fly higher than any Allied fighter. It could operate in air so thin that pilots in conventional aircraft would lose consciousness. It represented the culmination of piston-engine high-altitude development. And none of that was sufficient to alter Germany's fate or to justify the resources invested in its creation. History judges weapons not by their technical sophistication but by their strategic impact. By that measure, the TAR-152H barely registers. A footnote. A curiosity. An example of what happens when tactical excellence pursues strategic irrelevance. The true cost of Germany's response to the B-29 threat can't be measured in aircraft destroyed or missions flown. It must be measured in what might have been. Every hour of engineering time Kurt Tank's team devoted to pressurized cockpits and high-altitude wing configurations was an hour not spent improving the FW-190D, which could have been produced in useful numbers. Every kilogram of rare molybdenum alloy allocated to TAR-152 turbine components was material unavailable for Me-262 jet engines. Every test pilot killed in a TAR-152 prototype crash was an irreplaceable loss of combat experience that could never be transferred to younger pilots defending the Reich. The irony extended beyond just the TAR-152 program. German engineers had pioneered jet propulsion, creating the world's first operational jet fighter, the Messerschmitt Me-262, which entered service in July 1944. The Me-262 was genuinely revolutionary, capable of 540 miles per hour, faster than any Allied piston-engine fighter could achieve. Unlike the TAR-152, which was optimized for a threat that never materialized, the Me-262 addressed a real and immediate problem: Allied air superiority over Germany. But production was hampered by the same resource constraints that the TAR-152 program exacerbated. The Junkers Jumo 004 turbojet engines that powered the Me-262 required exotic materials, precision manufacturing, and uninterrupted production facilities. Allied bombing raids targeted jet engine factories specifically. German industry struggled to deliver engines in sufficient quantities. By war's end, approximately 1,400 Me-2, 162 seconds had been built, but only 200 to 300 were operational at any given time because of engine shortages and lack of trained pilots. One can only speculate what might have happened if the resources devoted to high-altitude piston interceptors had instead supported jet production. After Germany's surrender in May 1945, Allied technical intelligence teams fanned out across the shattered Reich, hunting for advanced weapons technology. Operation Paperclip, the American program to capture German scientists and engineers, found Kurt Tank still in Germany. Tank was offered positions by various nations. Argentina eventually hired him, where he continued designing aircraft, including the FMA IAE-33 Pulky II, a swept-wing jet fighter that bore little resemblance to the Ta-152. Tank had moved on. The high-altitude piston fighter was already obsolete. The Soviets captured the Junkers facilities and many of the engineers who'd worked on advanced projects. They found wind tunnel data, design documents, and prototype components from programs like the Junkers Ju-287, a forward-swept wing jet bomber that never reached operational status. Soviet engineers studied these materials extensively, incorporating German innovations into early Soviet jet designs. The knowledge transfer was immediate and practical. American and British teams focused on jet engine technology. They disassembled captured Jumo 004 and BMW 003 turbojets, studying the axial flow compressor designs that German engineers had perfected. The Germans had chosen axial flow over centrifugal compressors because it was more efficient and produced less frontal area, reducing drag. This design philosophy, developed under wartime pressure, would become the foundation for virtually every jet engine built thereafter. By the 1950s, the lessons from German wartime aviation development were thoroughly absorbed into Allied aircraft design. The American F-86 Sabre, which fought in Korea, used swept wings derived from captured German research. The Boeing B-52 Superfortress strategic bomber, which would serve for decades, incorporated jet engine technologies that traced lineage back to German axial flow turbojets. Even commercial aviation benefited. The Boeing 707, which revolutionized passenger travel in the late 1950s, owed debts to German high-speed aerodynamic research. But the Ta-152H itself left no such legacy. A handful of captured examples were examined by Allied intelligence, noted for their sophisticated pressurization systems and high-altitude optimizations, then largely forgotten. The piston engine was already giving way to the jet age. No post-war Air Force needed a high-altitude piston interceptor. The future belonged to jets, to supersonic speeds, to guided missiles. The Ta-152 represented the absolute peak of a technology that was simultaneously becoming obsolete. One aircraft survives today, that pre-production H-0 model in Smithsonian storage. Occasionally, aviation historians study it, marveling at the engineering sophistication packed into a piston-powered fighter. They note the pressurized cockpit seals, the boost system installations, the long, high-aspect wings. It's an impressive machine. But it's also a cautionary tale about the dangers of fighting the war you expect rather than the war you face. German intelligence correctly identified B-29 capabilities. They accurately predicted its high-altitude performance. They reasonably concluded it would be deployed to Europe using established strategic bombing doctrine. Every assumption was logical, defensible, based on available evidence. And every assumption was wrong because American planners had deliberately fed them false information through operations like Hobo Queen's Tour. The B-29 seconds never came to Europe. They burned Japanese cities from medium altitudes, where their supposed altitude advantage was irrelevant to mission success. Curtis LeMay proved that operational flexibility, the ability to choose the right tactic for the situation, mattered more than any single technical capability. A bomber designed to operate at 40,000 feet achieved its greatest successes, flying at 6,000 feet because the mission demanded it. Meanwhile, German engineers had created a fighter optimized to operate at 48,000 feet, defending against bombers that existed only in their intelligence estimates and their fears. The Ta-152H could do everything Kurt Tank promised. It could climb higher, fly faster at altitude, and operate in conditions that would incapacitate pilots in conventional fighters. It was a magnificent answer to the wrong question. War teaches hard lessons, but the hardest may be this. Technical excellence means nothing if you're solving problems that don't exist. Strategic insight matters more than engineering brilliance. And sometimes, the most sophisticated weapon is the one you didn't need to build. German engineers weren't shocked when B-29 seconds flew higher than any Flak could reach. They were shocked when the B-29 seconds never came at all. The altitude advantage they'd feared, prepared for, and spent irreplaceable resources to counter turned out to be less important than they imagined. Not because the capability didn't exist. The B-29 could indeed fly beyond effective Flak range, but because American commanders chose different tactics that made altitude less relevant than payload, range, and operational flexibility. The Ta-152H remains a testament to German engineering prowess and to the fog of war that obscures strategic reality even from the most brilliant minds. It was the right aircraft for a war that was never fought. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.